Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. Now make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 16 to the power of x is equal to 32. So right here, I want to find the value of x. So for my solution, first start with 16 to the power of x is equal to 32. So 16, this is the same thing as 2 to the power of 4. And 32, since we want to make both of these the same base, I need to find what power of 2 makes 32. Well, 2 to the power of 5, this is going to be double of 16, and double of 16 is 32. So 32 is equal to 2 to the power of 5. So now if I replace 2 to the power of 4 for 16 and 2 to the power of 5 for 32, I get 2 to the power of 4 to the power of x is equal to 2 to the power of 5. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. So in this case, I have 2 to the power of 4 to the power of x. So that's going to be equal to 2 to the power of 4 times x, and 4 times x, that's the same thing as 4x. So now I have 2 to the power of 4x is equal to 2 to the power of 5. Now, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, as you can see, both of these bases are the same. So if that's true, then that means both the exponents are the same as well, meaning 4x is equal to 5. So I have 4x is equal to 5, and this is a simple equation to solve. All I have to do is divide both sides by 4, these two cancel out, and I'll be left with x is equal to 5 over 4. So this is my answer. So now to check, my original equation was 16 to the power of x is equal to 32. And I know x equals 5 over 4, so I have 16 to the power of 5 over 4 is equal to 32. So now, 16, that's the same thing as 2 to the power of 4. So I have 2 to the power of 4 to the power of 5 over 4 is equal to 32. Now, this is the same thing as 2 to the power of 4 times 5 over 4 is equal to 32. These two 4's cancel out, so now I'm left with 2 to the power of 5 is equal to 32. 2 to the power of 5 is 32, so I have 32 is equal to 32, and this is right, so my solution is right. Alright, so I have x to the power of x is equal to 2 to the power of 2x. So if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. And if I have something in the form a to the power of m to the power of n, well, we know that a to the power of m times n, this is the same thing as a to the power of n times m, right? These two are the same thing because m and n, these two are interchangeable. So if a to the power of m times n is equal to a to the power of m to the power of n, this means that a to the power of n times m is going to equal a to the power of n to the power of m. And this also means that a to the power of m to the power of n is equal to a to the power of n to the power of m. So in this case, I have 2 to the power of 2x. So this is the same thing as 2 to the power of 2 to the power of x. And I can also switch these two. So this is the same thing as 2 to the power of x to the power of 2. Now I'm going to divide both sides by 2 to the power of x. So then these two cancel out, and I'm left with x to the power of x over 2 to the power of x is equal to 2 to the power of x. Now, if I have something in the form a to the power of m over b to the power of m, this is the same thing as a over b to the power of m. So x to the power of x over 2 to the power of x, that's going to be x over 2 to the power of x, which is equal to 2 to the power of x. Now 2, this is the same thing as 4 over 2. So now I have x over 2 to the power of x is equal to 4 over 2 to the power of x. So now I'm going to take the power of 1 over x on both sides. So now I have x over 2 to the power of x to the power of 1 over x is equal to 4 over 2 to the power of x to the power of 1 over x. Now x and 1 over x simply cancel out, so I'm left with x over 2 is equal to, same thing over here, 4 over 2. Now if I multiply both sides by 2, these two cancel out, these two cancel out, and I'm left with x is equal to 4. So this is my answer. Alright, so I have x to the power of 4 minus 25 is equal to 0. So to start, I'm going to rewrite 25 here as 5 to the power of 2. So now I have x to the power of 4 minus 5 to the power of 2 is equal to 0. Now x to the power of 4, this is the same thing as x to the power of 2 times 2. And if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So x to the power of 2 times 2, that's going to be equal to x to the power of 2 to the power of 2. So I have this minus 5 squared is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is equal to x squared and b is equal to 5. So I have x squared plus 5 times x squared minus 5 is equal to 0. So now this is going to give me two equations. I have x squared plus 5 is equal to 0, and I have x squared minus 5 is equal to 0. So for x squared plus 5 is equal to 0, let's first start with x squared minus 5 equals 0. I'm going to first start by adding 5 on both sides. So now these two cancel out, and I am left with x squared is equal to 5. Now I'm going to take the square root on both sides. So I have the square root of x squared is equal to square root of 5. Now the square root of x squared, that's simply equal to x, and the square root of 5, that's going to, this is actually going to be positive or negative square root of 5. So these are two solutions of x. Now I'm going to go ahead and do x squared plus 5 equals 0. So now to solve this, I'm going to first subtract 5 on both sides. So now these two cancel out, and now I have x squared is equal to negative 5. Now I'm going to take the square root on both sides again. So now I have the square root of x squared is square root of negative 5. Remember, the square root of x squared is simply x is equal to positive or negative square root of negative 5. However, the square root of negative 5, this is the same thing as the square root of 5 times the square root of negative 1. And if you guys already didn't know the square root of negative 1, this is equal to the imaginary number I. So x is equal to positive negative square root of 5i. So these are my 4 solutions to this problem.
Back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x equals 243, and our goal is to find the value of x. So whenever we're solving exponential equations like this, we always want to make our bases here, which in this case are 3 and 243, we want to make them the same. Because let's say we have a to the power of x equals a to the power of c, right? Because our bases are same in this case, we know that our exponents are the same as well. So we could just set them equal to each other. We know that x is equal to c. So in this case, if we make our bases the same, then we know that our exponents are the same as well, and then we can find the value of x easily. So we have 3 to the power of x equals 243. So how would we convert one of these numbers to make the other one the same as this one? Well, let's do 243. 243 is equal to 3 to the power of what? 3 to the power of 5. 243 is equal to 3 to the power of 5. So what we're going to do is we're going to write 3 to the power of x equals 3 to the power of 5, because 243 is 3 to the power of 5. Now, our bases are the same, so we know that our exponents here, x and 5, we know that these two are the same as well. So now, we could simply make these two equal each other. So x equals 5. And this is our answer. So it's as simple as that. And we already know that 243 equals 3 to the power of 5, so we don't really need to do any of this. We already see that 3 to the power of 5 equals 243, so we already know that x equals 5. So that's another way.